All right, hello everybody, and we have another example problem we're going to work through. This time it's a two-dimensional projectile motion problem. So it says a projectile is launched 1 meter above the ground with an initial velocity of 45 meters per second and 20 degrees above the horizontal. And I need to answer 3 questions. How long is the projectile in the air? How far does it travel? And what maximum height does it achieve? And those are the 3 typical questions you'll be asked to do in a projectile motion problem. Not always all of them, but usually 1 or 2 of them. And you might have to do all of them to be able to actually solve the problem. So the first thing I like to do in a problem like this is go ahead and understand the problem so I know what I'm looking for. I am looking for t ground, so the time it hits the ground, which I might just call t. How far does it travel is the range, or the x distance. And what's its maximum height is y max. All right, those are the 3 pieces of information I have. Now, to solve this problem, right, what I need to do is use some pieces of information I have. I know that I have 2 ideas going on, x and y. And in the x direction, I know that the only equation of motion I have is x is equal to vxt, or v, in this case, cosine theta t. In the y direction, I have something more complicated because I have an acceleration present. Because this is happening on the Earth, I have an acceleration, and that's the acceleration due to gravity. So I have a variety of equations I may or may not need to use, right? So I know that the y distance traveled is equal to the initial y plus vy t plus 1/2 gt squared. I know that the velocity at any time t is equal to the initial velocity plus in the y direction. So vy t, vy plus gt. And I also know that I could say something like vy final squared minus vy initial squared is equal to 2g delta y. And vy is just v sine theta. So now I can sort of draw a picture and have in my mind what's going on here. So I have projectile. It's launching some projectile with a velocity of 45 meters per second at 20 degrees, and it's 1 meter above the ground, so I end up with some path that it travels, which looks like a parabola, and it hits the ground lower than it started. So that's the picture of what's going on. So as I begin to solve this problem, I need to think, what is it that I need to know? Well, to know how far it goes, I need to know how long it's in the air. All right? And to figure out how long it's in the air, well, I don't know the velocity it is when it hits the ground, but I know the distance it travels when it hits the ground, so I want to use this equation. So we're going to figure out how long it's in the air and how far it travels first, and then we'll talk about the maximum height it achieves. So how do I figure out how long it's in the air? Well, I said I start with this equation that says y is equal to the initial y plus v sine theta plus 1/2 g, oh, I got a t here, t squared. And I know that when it hits the ground, y is 0. So I'm solving for t here, and it's quadratic in t, and I know yi v theta g. So I can use the quadratic equation, and I can say, well, t is actually going to be equal to minus b, so minus v sine theta, plus or minus the square root of b squared, so v squared sine squared theta, minus 4a, which is 1/2 g, c, which is yi, all divided by 2a, which is 2 times 1/2 g. I could simplify this equation a little bit, and I could say, well, 4 times 1/2 GYI is really just 2 GYI. And I could say 2 times 1/2 is 1, so I could just divide it by G. And now what I can do is I can plug in some numbers, right? So I know my initial velocity is 45, so minus 45 meters per second, sine 20 degrees, plus or minus the square root of 45 meters per second, that value is squared, times the sine of 20 degrees, and that value is squared, so sine squared 20 degrees, minus 2, g is actually negative 9.8 meters per second squared, times y initial, which is 1 meter, and I divide that whole thing by negative 9.8 meters per second squared. All right, so you have to ask yourself now, am I going to get a positive answer? What makes sense, what doesn't make sense here? So thankfully I'm subtracting a negative, so that becomes a plus. And when I plug this into my calculator, I get a series of values that look like this. So negative 15.39 meters per second, plus or minus the square root of 256.45, and this is meters squared per second squared if you look at the units. And then I divide all of that by negative 9.8 meters per second squared. So meters per second divided by meters per second squared gives me seconds, so it looks like all my units have worked out well. And now I get two answers. So if I plug in the plus, I get negative 0.06 seconds. So I got to be careful about all the minuses and all the pluses that are running around, okay? Or if I plug in the minus, I get 3.20 seconds. And of these two answers, I only choose one, this one, because the negative answer means that it happened in the past. And I don't really care what happens in the past because it doesn't have any physical meaning. The experiment starts at time t equals 0. The equation is only valid for the domain of t greater than or equal to 0. So I can just reject this guy and never have to worry about him. Typically when I have these problems and I have some initial height, I'm always going to get a negative time. And to get the positive time, I typically choose this minus sign, which might seem counterintuitive, but what I end up with is a negative value divided by a negative value, which is a positive value. Now to find the range, so this is sort of the answer to one of these questions, right? So it's the answer to part B, or part A here. And then to find part B, all I have to do is come back and say, well, the distance it travels, the range, x, is equal to v cosine theta, the time it's in the air. So that's 45 meters per second cosine 20 degrees times my answer here, 3.20 seconds. And that gives me an answer of 136 meters, 135.5. So now I've found the range. So the last piece of the puzzle here is to find what the maximum height achieved by this projectile is. And I've got a couple things I can think about to solve this problem. But really, the thing I need to understand is that when I'm at this maximum height, what has happened is the y velocity has decreased until it got to 0. And then it increases on the rest of the way down. So to solve this problem, what I can do is I can say, for this situation, I know that Vy final has to be equal to 0. Vy initial is equal to V sine theta. And now I could say, all right, Vy final squared minus Vy initial squared is equal to 2g delta y. All right, great. So I can solve for delta y, just dividing by 2g on both sides. And I can say that Vy final squared minus Vy initial squared divided by 2g is my delta y. So that's 0 minus 45 meters per second sine 20 degrees squared divided by 2 times negative 9.8 meters per second squared. All right, so that minus sign's outside, so I end up with a negative divided by a negative, which gives me a positive answer, which is what I should expect. And when I do that, I get 12.1 meters. And now I have to ask myself, is that the maximum height? Well, no, actually, right? That's the height from the initial height to the final height. So the maximum height would be this 12.1 meters plus the initial height, which in this case is 1 meter. And that's how I get to my final answer. So there's a couple tricks involved when I'm thinking about projectile motion, but these are the kinds of questions you typically get asked. Thanks again for paying attention.